In this video, we will see the time shift and the time reversal operation performed on a discrete time unit step sequence. So the discrete time unit step sequence is defined mathematically here. We have u of n equals 0 when n is less than 0, and it is equal to 1 when n is greater than 0. We can see the unit step sequence in this diagram, which is non-zero only for n0 to infinity. Okay, and we would also learn in the end that what is the range of the values of n, that is the range of the values of n, the lower range and the upper range, for which this product is non-zero. Okay, for which this product is non-zero. So let's try step by step. First of all, apply the time shift operation. Okay, the time shift operation of this time shift operation on u of n. The time shifted u of n would look like this, and here it would be either minus or plus n naught. Okay, now suppose I take some integer value of n naught, let's say it is 2. So we can find the time shifted version of n minus n naught is 2, and when in this form u of n minus n naught, it is actually the same as u of n delayed by 2 units or shifted by 2 units towards the right side of 0, shifted by 2 units towards the right side of 0. So if we want to draw u of n minus 2, it would be drawn like this. We have an index n is 0, 1, 2, 3 and so on, and our signal actually starts from 2, 3 and we have 4. Okay, 4 and so on. So the same signal dragged towards right by 2 units can be seen in the diagram, which is u of n minus 2. Similarly, if you have a signal which is u of n plus 2, suppose, so it's the same signal u of n drags 2 units towards right. So 2 units, if we drag it 2 units towards right, it would be now how the signal would look like if you drag the same sequence 2 units towards right. So u of n 2 units towards right, so it starts from, instead of 0, it starts from minus 2 and so on, and here it is 0. Okay, the signal is 0 here. So we can see the shifting towards left and the shifting towards right. So it's a time shift operation on the unit step function. Now let's see the time reversal operation, the time reversal. Okay, the time reversal is if you have x of n, okay, and you get you change the variable n to minus n, you get a sequence which is x of minus n. So it's a discrete time sequence which is reversed in time. How it would look like, suppose for a unit step function, we get u of minus n, okay. So u of minus n actually would be shifted everything towards right, or let's try this one. Let's try this one for u of let's try this one for the shifted version, so that we get a we had a shifted version of the unit step function, and that was u of n minus 2, which was 2 units delayed. Okay, we already have this in figure number 1, which can be seen. If we change the variable n to minus n, okay, instead of n we take minus n. Actually, this operation is same as taking the time reversed version of u of n minus 2. So we already have u of n minus 2 there, and if we see the time reversed version, it means we are everything towards the right side of 0 will be moved towards the left. So you can see here, I'm just plotting everything towards the right will go to the left, and everything towards the left will go to the right side. Okay, so let's plot this time reversed version. So here towards the right side of 0, it will come here at minus 1. So at 1 the function is 0, and that would, here we will get a 0 here. We get a 0 here. That at 2 the u of n minus 2 is unity, that will move here. Okay, so at 2 we will get a 1. At minus 2 we will get a 1. Similarly, whatever is at 3, that would appear at minus 3. Okay, so whatever is at 3, that would appear at minus 3, and so on. So this would be your signal. And similarly, you can also see whatever was on the left side, which was 0 here at 1, and it will go to the positive 1. 0 here, earlier before the time reversal there was a 0 here, it will go to 2, minus 2, and then a 0 at minus 3 will go to plus 3. So you have 0 here, 0 here, 0 here, and all these values are 0. At 0 we have 0, so it still remains the same. Whatever is at 0, it remains the same at its position. So u of minus n minus 2 is a signal which is non-zero only for the values of n, between minus infinity to minus 2. This range is very important. It's multiple times it is used in convolution and other it appears as the product of other signal. For example, suppose you have a signal which looks like this: a of n, u of minus n minus 2, and you are interested to know where this signal is non-zero, where this product is non-zero. Okay, where this product is non-zero. So you can see a of a raised to the power n is available for all the values of n from minus infinity to plus infinity, but this is only available in the range, in this range. U of minus n minus 2 is only available in this range, minus n to minus 2. So this whole product, the whole product, a of n, u of minus n minus 2, this whole product will only be non-zero in the for the values of n from minus infinity to minus 2. Similarly, you can think about the product a of n, which is u of n plus 2. Okay, and we want to find out where this product is non-zero. So we can immediately see that u of n plus 2, it is non-zero only for the values of n from minus 2 up to plus infinity. Okay, u of n dragged 2 units towards the left side. So it's only non-zero in this range. So it means this whole product will only be non-zero in this range, because for other values this term is 0, it will make the product 0. And if you are interested, just try this one. If you are interested in finding out u of n plus 2, the time reversed version of this signal. Okay, So you have minus 2 to infinity. It means the time reversed version will be, you can plot the time reversed version here. And for u of time reversed, u of minus n plus 2. So this version, the time reversed version of the u of n plus 2 would look like this. It would start from 2, then you have signal at 1, at 0, all are 1s, okay, all are 1s. So this is u of minus n plus 2, which is the time reverse version of u of n plus 2, which we just saw above. And this makes the whole signal, this makes this signal non-zero only in the for the values of n from minus infinity to plus 2. Okay, so this range is usually important, and you can find out the range is limited by this function, the unit step function.